Welcome everybody. Thanks for joining us today. I'm Poonam Yadav, ACM-W UK Chair and lecturer at University of York, UK. My co-host today is Anastasia Najrova, project coordinator at ACM-W UK. She said hi to everyone. I'm very happy to invite our speaker, Professor Elena Simperl, Professor of Computer Science at King's College London and a Fellow of British Computer Society and a former Fellow of Turing Institute. Today, Professor is going to talk about the human face of AI, how collective and augmented intelligence can help to solve societal problems. Without taking much of our time, I would like to invite Professor to start her presentation. Thank you.
Thank you, and thank you very much for having me today. It is unseasonably warm for a UK summer. I've been in the UK for 8 years now, so I can say that. I'm going to share my screen. Here we go. And then you guys, if you want to ask questions during the presentation, by all means, I'm happy to do that. Otherwise, it's just someone will have to tell me because I feel I don't see the chat. But I'm happy to take on questions whenever. All right, so I hope you guys are seeing my screen, yeah?
Yes, we can see you.
And I'm going to move this. I'm going to put the timer on. Yes, so today I'm going to tell you about some of the research myself and my team at King's College London are doing, which is at the intersection between people, data, and technology. And I'm going to give you some examples of societal challenges around public transport, around the climate crisis, where myself and my team have been building systems and providing frameworks and guidance on how a combination of people, data, and technology could tackle some of them. I'm going to start by just explaining briefly what I mean by the terms in the title. Say, we start with this concept of augmented intelligence, which is basically AI, artificial intelligence, but it refers to a certain way of seeing AI and understanding its use and its implications. So it refers broadly to a way to design systems that use artificial intelligence in a emphatically human-centered way. And the idea is that you use AI and you design a system from the beginning so that people, whether it's the users of the systems or people who contribute to the system in other ways, people and AI work together to enhance human capabilities like cognitive performance, learning, decisions, or even enable new experiences. There is another aspect of this interaction between people and AI that is worth mentioning, because perhaps unlike other technologies, AI depends on human input in some very specific ways. Say, machine learning in particular, or any sort of data-driven AI approach, is only as good as the data that it has, and more often than not, that data needs to be labeled. Labels come from people, for instance, through the use of specialized labeling platforms, online platforms, but also in other cases, applications do find themselves in a situation where they need more data or better data. So one of the examples I will bring in later on in my presentation is around mobility patterns, understanding mobility patterns in urban areas. And to do that, we realized that the data we have about those mobility patterns is just not sufficient, and you need to collect more. And finally, AI is much more than machine learning. There's various other types of approaches, symbolic, neurosymbolic, knowledge-driven. So the area I originally come from is knowledge representation, where we build large knowledge bases that teach AI applications, how a domain looks like, what sort of things are in that domain that people might be interested in. So encoding that knowledge in a way that computer systems can use it is and remains and will remain a manual process. So not only that, we need to think about AI applications in this sort of augmented intelligence way, in this sort of human-centered way, but also we have to realize that perhaps more than other types of technologies before it, AI applications really depend on human input. And there is a particular type of human input and interactions that I look at in my research, because it is particularly interesting, but also particularly valuable. And those are situations that showcase what we call collective intelligence. Collective intelligence is a very broad interdisciplinary term referring to a phenomenon that emerges when a group of people, a community of people achieve a common goal implicitly or explicitly. So the typical example for this is, for instance, something like SETI at Home, which is a large initiative, global initiative, where people can donate computational cycles from their computers to help run large experiments, but also things like OpenStreetMaps, which is an open source, freely available map that has been created with the help of many volunteers. And I will come back to OpenStreetMap in one of my examples. So this is a particularly interesting type of application that I look at in my research. But in the context of AI specifically, it offers a series of techniques, of methods that are really, really useful, that are core actually for machine learning to create training data sets. So some of you might be familiar with platforms like Mechanical Turk, like Figure 8 and many others, which enlist the help of millions of people to create fundamentally training data sets for different types of machine learning algorithm, for text processing, for computer vision, and so on and so forth. The way to manage that labeling process, to ensure the quality of the labels, to ensure the use of resources in an effective way, comes from collective intelligence. So this is sort of the background of the research that I'm doing. It's fairly interdisciplinary, just by the nature of the topics it covers, and as such quite challenging to investigate. And the sort of fundamental question that I look at is how one would design a system, an IT system that brings together these different types of capabilities: human intelligence, collective intelligence, computational intelligence, in the form of AI nowadays, for mutual benefit. And there's all sorts of challenges associated with this. First, related to human factors, so bringing together people and machines has its challenges. I hope you agree. But going further, if you enlist the help of labelers, of volunteers to perform steps in a computational process, then you have to think about how that computational process needs to be structured and operationalized, because on the one hand, you have algorithms which are good at some things. On the other hand, you have people which are good at very different things. And further than that, there's more challenges when it comes to managing not just individual contributions, but actually crowds of people with their own behavior and dynamic. So in this talk, what I'm going to do is present you some design patterns, some architectures for systems that are trying to combine these different elements in interesting and useful ways. And I'm going to tell you about some of the challenges that as a system designer and researcher in this space you have to be aware of, and point to some directions for future research. The first example I'm going to bring up is a project that we have completed just a few months ago. It was funded by Nesta, by the Collective Intelligence Design Center, through a small grant. And the societal challenge that we're looking at is disaster relief and how human computation can provide help in managing crisis on the ground. This could be quite a powerful instrument. So the example I have here on the slide is of a platform called Ushahidi, which is a collective intelligence digital platform to coordinate people when they collect data on the ground or analyze it. So in the Haiti earthquake, which is depicted here, there were more than 40,000 independent reports that were mapped through this large volunteer effort. And I believe this was true at least a few years ago, but Haiti now has one of the most accurate Google Maps on Earth because of these efforts. So what happens in a situation like this is that crisis teams on the ground have to sift through large volumes of information, of crowdsourced reports that arrive to them from social media or through other sources. And at least at the beginning of a crisis, there's a lot of goodwill, there is a lot of participation from volunteers to help crisis teams in various ways. But as you pass through this, after this initial phase of the recovery and when media attention is perhaps not so high, you notice that this volunteer participation goes down dramatically. So then the question becomes, how could you make the most out of these remaining contributions? And we have looked at two areas there. One is learning. So if there is a smaller set of people who are still willing to contribute beyond this initial recovery phase, how can we make sure that they are as effective as possible if they are really around to help us for longer periods of time? And how do we make sure that they stay engaged with the effort? So we've done two online experiments to try to address this. In the first one, we have looked at how do we allocate tasks. So if you have a group of people that come together to help you, in this case, help you structure, organize, filter through information from the ground, how do you do that in a really effective way rather than just allocate tasks to people as they arrive, which works when you have lots of resources, but is not as effective as these resources diminish. So the approach that we wanted to take is to increase learning and engagement by trying to order the sort of tasks that each person is supposed to do in a particular way. And we looked specifically at difficulty, and I'll explain a little bit later why difficulty and not something else. So the experiment itself was run on a public data set of tweets about three types of hurricanes events that occurred, where we worked with an environmental scientist with a background in disaster relief, and curated this data set manually to around 2,000 tweets with text and images. And then we have asked the crowd of volunteers recruited via the Mechanical Turk online platform to classify these tweets to help recovery team process them better. And the classification was basically, you can see that in the picture on the bottom of the slide better than on the top. Basically, we were showing people a tweet and we were asking them, what is it? Is it a request for help, an expression of a personal experience? Because that's the sort of triage that happens in crisis teams and helps organize actions. And in the experiment, we then tested three conditions: a random baseline where we have taken the tweets and give them to people in random order, versus one where the tweets were increasing in difficulty and one where they were staying at the same level. And we've monitored how accurate the answers were, and we knew accuracy because we had two experts looking at each tweet and basically identifying the correct answer. So the findings were to some degree surprising, to some degree confirmed what we thought. Accuracy is influenced by difficulty. So if you have a tweet where it is not clear what recovery phase the information belongs to, then it affects how well people can spot that. It was slightly different for tweets that included only a text post versus the ones that included images alongside text. We didn't find any significant association between difficulty and the volume of completed tasks. So initially we have thought, inspired by gamification and game design, that if tasks are ordered in an increasing level of difficulty, then people perhaps would get less bored and would continue to do more work. And that would be the point, to say that actually, so each participant could stop classifying at any point in time. So that was sort of the findings from the first experiment. In the second experiment, we have tried to see whether we could teach people to be better at this information filtering task, and we have provided two types of feedback to them. One was a feedback from an expert. So for an answer, when someone gives an answer to a classification task, we know the answer from the gold standard, and we show it to them, and then we give people a chance to say whether they think their answer is correct or whether or matches the expert feedback, and if it doesn't, they have a chance to change it. So two forms of feedback. In one case, we've taken the golden standard, so the correct answer from the golden standard. In the other one, we've just taken one of the other answers from the crowd. And again, we have monitored for accuracy. We've also asked people to provide justifications and analyze those. So the results here were quite striking. So participants were generally really poor at taking feedback into account. So as many as 57% of them felt that the gold standard matches their responses, and this was often not the case. So that raises some questions about the design of the task and the understanding, but also it raised some questions around how we could present that feedback in a way perhaps that is more accessible to people. Another interesting finding was that people reacted to feedback from their peers versus feedback from experts in different way, but in the same time, so they were more likely to change their answers in response to crowd feedback, which is interesting. So they've seen someone else's answer and they were more likely to change theirs, but in the same time, they were less trustworthy, or they had less trust, less confidence in this information from their peers. So this is a space where we're definitely going to do more experiments to try to understand where these effects come from, how we could perhaps come up with new ways to present this feedback to improve accuracy. So as future work, for this first example, so the fact that difficulty did not have an effect on engagement was something we didn't really expect. So in a different experiment, where we had tried out different incentives and game narratives to reward people who help in volunteer efforts and labeling tweets, we had very different experiences, but perhaps it's also worth saying that in that previous experiment, we have built a whole design, gamified design of the tasks, which we haven't done here. So it would be actually interesting to see how that custom-built interface for filtering the information, classifying the information played a role in convincing people to do more work, to contribute more, which is something that we didn't really think before. And then the other piece that we would want to look at is how we could then perhaps personalize the feedback rather than providing something generic or presented in different ways. The one thing that is worth saying is that personalized feedback is quite resource intensive to do, because in most cases it would probably require manual intervention from the crisis team, and this is something that they probably wouldn't have the resources to do. Right. So the second example I wanted to talk about today is in the area of city maps. So information that is available to public authorities to take decisions. This information is often out of date, and by that I don't mean where the streets are or the intersections are, where perhaps traffic lights are, but many other so-called points of interest information on maps are quite quickly outdated. And the way city authorities aim to update these data sets is quite expensive. So they're using traditional survey methodologies where every 3 years or so they send someone to explore a particular designated area of a city, and then from that extrapolate on numbers of specific points of interest for the entire urban area. The other approach is OpenStreetMap, so so-called VGI, Volunteer Geographic Information, where you have a community of volunteers who create their own maps, go about and explore their street or further areas, and basically add that information to the map for everyone to use. That OpenStreetMap is a huge success. At the same time, it is not always directly usable for city authorities because they have very little control to ask the OpenStreetMap community to go and collect specific types of information for them at particular times or by a given date. So to deal with this challenge, we have looked at how we could use on-demand volunteer effort, so-called paid microtask crowdsourcing, through a custom-built tool called Virtual City Explorer to collect this information without requiring people to actually be in that city and go on the street and audit it. So we have built a tool called the Virtual City Explorer, which uses digital street imagery. So something like Google Street View, for example. So if you're a civil servant working for a city authority, you in the tool you can define an area of the city that you're interested in and a particular type of information that you would want people to collect. In our case, we looked at particular types of parking spaces for people with disabilities, but also we looked at locations of bike racks, which in many cities in Europe are managed by different private providers, so the cities don't always have the information about those locations very accurately. So the idea is that the city planner, like I said, selects an area, and then the tool, the Virtual City Explorer, is connected to this online labor force platform, Mechanical Turk, where we recruit people to virtually explore the city and collect the information. If you go at this link, you can try both views out. And you can also download the tool itself from GitHub. GitHub is available open source. So practically what we're trying to do is we're saying, instead of sending your own people on the ground to survey, or instead of relying on a community of volunteers who do things in their own time, you could perhaps try to complement or supplement or validate the information that you already have by seeking help from a crowd of volunteers that are available through this digital platform. And there's a whole range of challenges associated with doing this. The task itself is quite exploratory. So, excuse me. So it is not always easy to say where it starts and where it ends. If you think about how one explores a city, and if you consider the fact that you actually don't know where those parking spaces or bike racks are. Like with everything that is not a traditional established data collection methodology, there are questions around data quality. There's also questions like in the previous example around motivations and incentives and participation, but also because the task is explorative, inherently some people will do more work than others. So the question about fairness of rewards becomes quite important. So we've trialed this virtual city explorer with 2 cities, one in Italy, one in France. We've recruited 150 participants online, and we have basically asked them for 2 designated areas. So the Trento one is here, the Nantes one is here, to go and explore the city virtually using Google Street View and take pictures of 5 bike racks in our case, and for each of these 5 bike racks that they were discovering, we were paying them a small amount. And we've looked at a number of elements. We've looked at feasibility, at completeness, coverage, and I'll explain a little bit what I mean by that. So in the first instance, we wanted to get a sense of how feasible our approach was. So here at the bottom of the screen, you see images from Google, taken from Google Street View, that show different types of bike racks. Now, the first question is, how does someone tell you where those bike racks are if we're interested in their location? And the approach that we have come up with there is to ask people to basically take a screenshot or a photo shoot paradigm of that point of interest from 3 different angles. And these 3 different angles were important because we had used the geospatial algorithm to basically compute the exact location of that bike rack. So we first tested to see whether that works and leads to accurate data. And then also we have checked manually on a sample to see whether they actually send us pictures of bike racks or of other things that they see in the city. And the answer was quite encouraging. I mean, you see here in this graph that the precision drops. The precision drops not because people become more careless as the task progresses, but because there are fewer and fewer bike racks to find as more and more people join and explore that area. We were also fairly happy with data completeness. Completeness is basically, did they find all those bike racks that were available there? And to do that, we had to compare the data that they submitted with other data sets, like the ones that the city authorities had or OpenStreetMap themselves, all of which were incomplete by some metrics. So the result was that indeed the approach is able to find new points of interest, in our case bike racks, and basically is a way to update official data sets in that space. We've also looked at coverage. So if a city planner draws a polygon of the shape presented here, do people really go and explore all of it? Again, we were quite happy with the results, as you can see in this heat map here. And finally, we've looked at the experience. So Most participants, so the graph on the top, those bar charts, presents the number of errors that people encountered, and there are various things that that could lead to errors when they explore the city. Say, taking those 3 pictures means that people had to zoom in and out and move around so that they could take 3 different pictures that we could accept. So that was one activity that some could have found difficult. Some went outside the designated polygon and a few other things, but in most cases the interface worked and the experience worked quite well. We also received positive feedback on the experience and on the payment, despite introducing what we call a taboo mechanism. Now, this mechanism, I'm not going to have time to explain it, but practically what happens is, if you see in these coverage maps and these heat maps, you see some areas are marked in red. So those are areas that were explored by lots of people from these 150 participants we recruited per city. So this means that in some areas, for instance, this main street here in Nantes, we had bike racks that were confirmed by lots of people. We wanted only 5 confirmation to be confident enough that that's indeed the location of a point of interest. But in the same time, because we didn't control at all how people explore the city, which is part of the design feature of the Virtual City Explorer, we also wanted to make sure that we don't have, the same 10 bike racks in the center of the city confirmed by 100 people and some others on the fringes of the area perhaps receiving fewer confirmations. So because of that, we've introduced basically this taboo mechanism where after a number of confirmation, we would retire that point of interest, and people would see a sign basically when they arrive to it saying, okay, no, this one's already taken, we don't need information about it anymore. What that means is that when people, as these 150 people join at different points in time, the ones that join later have perhaps lower chances of completing the task than the ones that are there early on, which is a question of fairness that we need to take into account. And the way we have tried to balance that out was through by observing what is sort of the average distance that someone explores in the city that would give us a signal that that particular participant have tried perhaps to find and to complete the task, but just didn't had enough points of interest left to do it. Finally, what we have also noticed in the crowd experience study is that there were quite a few participants that dropped out that didn't seem to try to complete the tasks. So these are the graphs here for the 2 cities. So these lines here are what we think is the time or the distance explored on the map. That is typically a signal of someone trying their best to complete the task. And you have these blue crosses here, which are people that have tried more or less to do it or have actually decided to drop out before. So if we want to improve on any results in terms of accuracy or completeness or coverage, this basically tells us that we should not recruit more than 150 people. Those would be enough, but we need to find ways to engage the ones who are likely to drop out. Here's a summary of the data set that we have collected through these means. So this was basically this is for the city of Trento, their own information. So it takes practically around 4 hours to collect the information about the bike racks that they already had with this 39 points of interest, versus the information that is collected through the OpenStreetMap community that has more points of interest, but it's collected by 2 volunteers according to the data that they have. But there's also no means to ask these people to update them, versus our approach, which you can do on demand whenever you need it. It takes it took us 7 days to get all the data completed, but compared with the update rates of the city, this is quite manageable. There's a lot of future work there that I could mention. Say, I mentioned briefly that the task itself is quite exploratory. So another approach to do this, instead of just asking people to explore the city at their own leisure, and starting from a random position, we could think about ways we could allocate these starting positions so that you can maximize coverage. You could also think about feedback, sort of similar to what we had in the Nesta experiment, where you would show people where the other participants are on the map so that they can develop their own strategies to collect the information, perhaps from the areas that are less explored. We would also want to understand the impact of urban topology on all the parameters that we have monitored, and perhaps run a study where we directly compare what happens on the ground when someone surveys this information with an online approach. My final example for today is around mobility patterns. So mobility, so transport in cities is a huge challenge. So we worked with the city of Trento in Italy in the Crowd European project that finished at the end of last year, to try to collect information, improve the way they make decisions on public transport policies in the city. And they were interested in a particular type of trips, of journeys that people take in the city, which was called in transport and logistics model split. So this refers to journeys that people take in a city that involve more than one type of transport. So say you go by bike up to the next train station, then you get on a train, you switch perhaps to the tube, and then you do the last bit by foot. So these sort of journeys, collecting information about these sort of journeys is quite complex. And the city authorities were interested to see whether we could come up with a methodology, an alternative methodology to do this, using machine learning, location-based data collection, and crowdsourcing. And this is what we have implemented here. So we've implemented this quite complex workflow. We've built a mobile app where that recruits people and records basically their journey. There is a machine learning classifier that looks at each of these digital traces and tries to infer first the start and end point of a journey, and also the different segments that were using different types of means of transport based on accelerometer data and location. And then we had a feedback loop to validate some of the predictions of the algorithm. So I'm going to talk about this particular validation step and the challenges we have encountered there. One of the challenges really was around the user experience, and I'm not going to have time to discuss this in great detail, but this is to emphasize that for this type of information, and there are many other examples where we have to go out and present to people what the machine learning algorithm has computed, you need to think about how you present that information to people in a way that they can understand it and they can provide reliable information. So this is the scenario here was, what were your journeys? Where were you today? And how were those journeys broken down depending on the type of transport you have used. Say there's all sorts of questions, usability, user experience questions around how you present that. Initially, we presented this on a map. So the picture here at the bottom of the slide is one of our initial thoughts, where we looked around. We tried to present start and end points on a map. We tried to depict different segments of the journey that the machine learning classifier had inferred in different colors. Overall, we had a lab in the city of Trento with over 250 participants. And the interface that we ended up using is something really, really different, where we have a timeline of someone's day, and we show on the left-hand side what we think were the means of transport that they were using, and with the highlight of the location there, and basically this was the approach that led to best engagement and data that was also very quite accurate. Regarding the accuracy of the data, we've also done a second experiment to try to understand whether people, when the algorithm makes a mistake in detecting, for instance, the end of a journey, or the location where a car has stopped versus a car has just stopped at the traffic light. We wanted to see whether, if we present this information to someone, can they actually detect errors? And we've done this using first this interface here, which was the one that worked best in our experiments, but also in a dedicated study where we have just used Google Street View and Maps, and we have basically artificially introduced errors in this sort of multimodal journeys, and try to understand how much people, how accessible this sort of questions are to people, and whether they remember what they've done regarding their own trips. So the naive model we have started with assumed that people will notice and they correct journeys detected by the algorithm, at least if we present this information to them timely on the same day they took the journey. But if that's not true, is there a way for them? So do they tend to detect those errors? And is there a way for us to estimate the residual error rate? And finally, how do people go about thinking about their past journeys and the different means of transport and checking them? This is still ongoing work. This is the interface that we have used to run the experiment. And like I briefly mentioned, we basically looked at a set of journeys that people have actually taken on Google Maps, and we have injected artificial errors and basically checked whether people noticed. So the experiment with 10 participants, we had 5 journeys per participant, and we've added 4 types of errors. One where there was what we call under or over segmentation. So segmentation refers to splitting a journey into segments that were done using a certain means of transport, so train or bicycle. Bad mode, so instead of car, we have predicted the person walked, and bad locations. There's a paper coming up about this where we present more findings, but practically this opened our eyes to a whole space where we need to do more research into how these data collection methodologies that lots of people, lots of businesses are doing to feed into algorithms for public transport, for route planning, for any sort of urban decision, how much research we still need to try to understand and how good that data is. And by that, I don't mean typical challenges that are quite widely discussed around biases and digital divide and whatnot, but really the ability of people to engage with their own data about their own lives and journeys through the interface and experiences that we're providing them. So to sum up, if we go back to the question I had asked at the beginning of the talk around how do you design systems that bring together data, people, and technology to solve important challenges of our times, a mix of approaches. So I have presented different ways to collect data, to analyze data using different types of digital platforms, custom built tools, depending on the sort of information and processing we wanted people to help with. I've also briefly touched upon the question of human factors and user experience design, which is really something that we need to do more of. So for something like multimodal journeys, which is quite a common topic in public transport, it has turned out that we know very little, and I could imagine every other scenario in an urban setting where you need data that is traditionally done with survey methodologies. You would need very similar types of studies and resources for that. We also need to be mindful of data quality and have means to assess it, and use data science methods to observe how people interact with these systems and interfaces and adapt them. And finally, like with every type of system that seeks help from people beyond regular interactions that people do to use the system, we need to think about how would we convince someone to do some extra work to help AI algorithms improve. And I'd like to close by thanking some of my colleagues from my former team at Southampton, as well as the Crowd project, where we've done the last 2 of the 3 examples, Nesta for funding us for the first example, and the European Commission that has co-funded the Crowd project. And here are some publications in case you're interested in finding out more about the research. So the first one is about the Virtual City Explorer. There's the link here as well. The last 2 are brand new reports. This is the report that Nesta has published about our experiment, as well as others that were funded in the same collective intelligence call. And here is what I thought was a very well written summary of our findings for a wider audience, which is hopefully more accessible than anything we academics could write. Well, thank you very much for having me, and if there are any questions, I'd be happy to answer them now.
Thank you so much, Professor, for a very interesting presentation and covering quite varied topics, basically, in your area of research. Right now, if someone has, please, any question, either raise hands or type your question in the chat window. You can moderate that. I can't see. So in meantime, I have one question, because I worked previously in a similar Citizen Cyber Lab project, which was FP7 funded project a couple of years ago, and did quite a lot of work in crowdsourcing and volunteer motivations and everything. So one of the question, for example, for some of your project, you use Mechanical Turk. I found whenever we use Mechanical Turk for any of the experimental studies, these are a bit of, the volunteers are not like a random general public. How did you find that kind of a variation in volunteer recruitment itself in your experiments?
Yeah, thank you for that. I think that's a fair comment. I think what I would want to add, perhaps, and I didn't have time to go into dive too deep into this during my presentation, is that so in the research we are using Mechanical Turk almost as an additional platform. So Mechanical Turk is quite difficult to use to solve real problems. So if you think about city authorities, you don't even have the business processes to pay for volunteers to do things. So it's much more. It's much more basic than that. So we're currently talking to some cities in Spain about this, and one of the first question they've asked, just like the colleagues in Italy as well, was so if we were to do that, how much would it cost? And we have addressed that by trying to manage the resources as much as possible. But it is also like, how do you pay for that? Because there are no procurement processes or anything like that. So that's one of the reasons why if you want to build workflows like that, you can't rely on Mechanical Turk. But it is a useful resource just to complement what is already there. So survey methodologies that will still continue to exist because people trust them. Whereas the ones that we have proposed and other people have proposed using social media and other types of proxies are just not established enough for authorities to use them with confidence. That situation is changing, but it's not the case at the moment. So you use that only to add on top of what is there. And you also use it sometimes to just get a sense of whether the design that you're proposing would work. So for the Virtual City Explorer, we have used it in a citizen lab in Italy on the ground. So we went and engaged with teenagers, with people who participate in open days of the city. And they use the same sort of digital tool rather than, or in addition to walking around and collecting that information, to submit that data. So it's less of a question of how representative the Mechanical Turk population is for these particular challenges, because it isn't, but it is more about their role, and their role really is to complement existing processes and data collection methodologies that cities and NGOs like in the disaster relief scenario already use.
Thank you so much. Yeah, I agree with you. Does anyone has any more questions? Please either type on the chat window or raise your hands or unmute yourself and ask yourself. So another question coming from me again in the meantime. The other question was, I was thinking about, for example, this open map problem which you discussed. How much now is the privacy is one of the biggest challenge, and how you said volunteers could see the other volunteers what they are doing and they trust them more. That was a very interesting results. Basically, was very fascinating for me to see from a trusting point of view that people trust their peers more than
Yeah.
the authority when you're giving them
Yeah.
feedback. But from that perspective, also, whether do you disclose them who is putting, who are your peers in this scenario, or is it allowed? So there are two questions basically here.
Yeah, that's a very interesting space. So for the perhaps just to clarify a little bit the concerns, the for the location-based app, so we have used state-of-the-art practice in getting consent and storing the data according to GDPR principles, including minimization and so on and so forth. So that was, people were seeing their own journeys and had to validate their own journeys, not someone else's. In the other case where we have shown other people's answers, we didn't have that privacy concern because we were operating with public tweets. Having said that, there is a space, a whole area of research where companies are not using public tweets, but are using, documents and images and information that is confidential or commercially sensitive. And there you really have that dilemma. How much can you actually show this to labelers without disclosing too much? And the approaches, I don't work on this, but the approaches that I have seen are, for instance, if you think about an image, they don't disclose the full image for classification, but they're trying to think of ways to fragment, to image fragmentation, or show only certain parts of the image. So they show enough to allow someone to still answer the question, what do you see in the image? But they don't show the entire content, which would basically disclose too much of that commercially sensitive information. So those are the sort of techniques that I have seen. in other cases, I think companies that use a lot of human labeling to train machine learning algorithms, they have data sharing agreements and confidentiality agreements with their platform of choice to do this, to mitigate some of those risks.
Okay, so we have a question from Lipika Deka. She just asked, just as a thought, should there more work on developing ML algorithm that can work with inaccurate data while parallelly working with methods for better collection of data? There's always chance of volunteers manipulating the data.
So if I understand the question correctly, is it about the quality of the data that is used to train the algorithms?
Yeah, so I think there are two questions here. One is inaccurate data itself, and the other is if volunteer intentionally manipulate the data.
Yeah. So to start with the second question, there the main thing to think about is why are people labeling in the first place, and there is a huge difference that is established through data and various studies that in contexts where you pay people for labeling, they will have a different motivation, and the quality will and spam will be an issue. And there's ways to mitigate that by using data science, basically, and pattern detection of behavior that can lead to spam or so-called qualification tests. So if you think about asking someone to label 10 images, 2 of those are images that you know the answers for. One of them is very basic. So the assumption is that if someone is a spammer, they wouldn't really pay attention at all to any of the questions. So they would get the one that they should not get wrong, and basically you can eliminate for that. And there's all sorts of answer inference mechanisms as well. So if you get 10 labels for the same image, then there's answer inference mechanisms that compute the answer, the label that is most likely to be correct, depending on all sorts of factors. So that is around the accuracy and so it's the manipulation. And for the accuracy, I think it depends very much on the type of tasks. I think for some tasks you can think about accuracy when you can imagine that there is one correct answer. So what I haven't spoken about at all is tasks where there's lots of subjectivity, for instance, and then you have to go about the question of what is a correct answer, what is a valuable answer in a different way.
Okay, thank you so much. There is one more question from Petra. Sakia, thinking about the approaches to use human volunteers, paid worker more broadly, do you have any concern about extending precarious work conditions coming back to our theme of AI for social good?
Mm-hmm. Yeah. So there are concerns, and there are. We have done some research in this space as well, but I haven't presented it today. So the thing that everyone, at least in academic research that is subject to ethics approval and so on and so forth, is doing is piloting the task, having a good understanding of how long it takes to solve it, and then paying above minimum wage, US minimum wage for the tasks. So that is something that, to be honest, it took a while for the community to get there, but it is now, I would say, established practice. Beyond that, we've been doing some research around fairness of crowdsourcing. In particular, we were looking at the value of the data that people help generate and how that value is, the benefits of someone using that data could be shared more broadly. And we've been we're experimenting, but this is still quite new, and I don't have very good answers to this. But we're thinking about models of data sharing and value sharing and things like data trusts, to think about using managing the benefits of crowdsourced data more widely. And this applies not just to Mechanical Turk, where you have an explicit contract, here's the image, we want labels for it, but that applies to any sort of algorithm that is using implicit feedback, like almost any web algorithm and search and recommendation and so on that is using implicit feedback data from us, data also about us, to some degree, to feed those algorithms. So we're creating this crowdsourcing data sets that are used to train very large models and generate value in some ways that people are increasingly saying is perhaps not very equitable or ethical.
Okay, thank you so much. Any more question, please? I think we are done with this.
All right.
Thank you so much for your very interesting.
Thank you for having me and for the questions, and I wish you all a lovely afternoon.
You too. Thank you everyone for joining us today. Before disconnecting